Now, let us discuss the surface area of a right circular cylinder. In day-to-day life, we have come across three-dimensional objects like tank, logs, and many more cylindrical objects. How do you measure them in mathematical terms? Let us see how to go about it. Here, have a look at this cylinder, which does not have the top and bottom surface. So, here we deal only with the curved surface area of the cylinder. Unlike cube and cuboid, we call them as lateral surfaces excluding top and bottom surfaces. But here, for cylinders, we call them as curved surface area instead of lateral surface area. Now, what if we try to cover the cylinder with a colored paper? How will we do it with minimum amount of paper? First, take a rectangular sheet of paper whose length is just enough to go around the cylinder and whose breadth is equal to the height of the cylinder as shown. The area of the sheet gives us the curved surface area of the cylinder. Note that the length of the sheet is equal to the circumference of the circular base, which is equal to 2 pi r. Therefore, curved surface area of the cylinder is given by the area of the rectangular sheet. That is length multiplied by breadth. From the figure, we know that length is given by the perimeter of the base of the cylinder, which is given by 2 pi r, and instead of breadth, its height in the case of cylinder. Therefore, 2 pi r h gives us the curved surface area of the cylinder. Now, what if we have closed the top and bottom surface of the cylinder? We know that area of the circular base is pi r square. Here, we have two of those faces, that is 2 times pi r square. Also, since we need to know the total surface area of the cylinder, we also add the curved surface area, that is 2 pi r h, to 2 pi r square. Taking 2 pi r common, we get 2 pi r multiplied with sum of r and h. Pi is an irrational number with a value 22 by 7, which is equal to 3.14. We will be using this value frequently in our problems section. Let us now consider a problem. The curved surface area of a right circular cylinder of height 14 cm is 88 cm square. Let us find the diameter of the base of the cylinder. The solution for the same is as follows. The height of the cylinder is given by 14 cm. The curved surface area of the cylinder from the question we read it as 88 cm square. And the curved surface area of the cylinder is 2 pi r h. That is 2r is equal to d, which implies that 2 times the radius is diameter. Therefore, the curved surface area of the cylinder is equal to pi d h, which is equal to 88 cm square. Plugging in the values, we get 22 by 7 into d into 14 is equal to 88. Therefore, d is equal to 88 into 7 divided by 22 into 14, which is equal to 2 cm. Now, let us get into another problem. A metal pipe is 77 cm long. The inner diameter of a cross section is 4 cm, and the outer diameter being 4.4 cm in the diagram. Let us now find its inner curved surface area, outer curved surface area, total surface area. So let us now solve the first subpart, that is inner radius of cylindrical pipe, which is equal to r1. So that is inner diameter divided by 2, giving you 4 by 2, which is equal to 2 cm. Now the height of the cylindrical pipe is given as h, which is equal to 77 cm. Therefore, the curved surface area of inner surface of pipe is equal to 2 pi r 1 h. Plugging in the values, we get 968 cm square. Outer radius of cylindrical pipe, so that's the second subpart, we consider that as r2, which is equal to outer diameter divided by 2, which is equal to 4.4 divided by 2, which is equal to 2.2 cm. So, the height of the cylindrical pipe from the question is again h is equal to 77 cm. That is, curved surface area of the outer surface of the pipe is given by 2 pi r 2h. Same as plugging in the values, we get 1064.8 centimeter square. Now, area of the base is equal to the area of circle with radius 2.2 centimeter subtracted from area of circle with radius 2 centimeter. That is pi r2 square minus pi r1 square, that is 22 divided by 7. In brackets, we have 2.2 square minus 2 square. Solving the same, we get 2.64 centimeter square. Therefore, the diameter of the cylinder is 2 centimeter. Now, the third subpart is to find the total surface area of the cylindrical pipe. So, the total surface area of the cylindrical pipe is given by 2 pi rh plus 2 pi r square. That is, curved surface area of inner cylinder plus curved surface of outer cylinder plus 2 into area of the base. So, let us now plug in the same, that is 2 pi r1h plus 2 pi r2h plus 2 pi r square. Substitute the values from the question and then we get 2038.08 centimeter square. Therefore, the total surface area of the cylindrical pipe is 2038.08 centimeter square. Now, let us get into another problem. A cylindrical pillar is 50 centimeter in diameter and 3.5 meter in height. Let us find the cost of painting the curved surface of the pillar at the rate of 12.50 rupees per meter square. The solution for the same is as follows. So from the problem, we identify that diameter is 50 centimeter and h, that is height, is equal to 3.5 meter. Can we just find the radius of it? That is 50 divided by 2, which is equal to 25 centimeter. So converting the centimeter into meter, we get 0.25 meter. Therefore, the curved surface area is given by 2 pi r h, which is equal to 2 into 22 divided by 7 into 0.25 into 3.5, giving you 5.5 meter square. Now, cost of painting 1 meter square area would be rupees 12.50, right? So, what would be the cost of painting 5.5 meter square area? That is rupees 5.5 into 12.50, giving you rupees 68.75. Now, let us summarize. The curved surface area of a cylinder is given by 2 pi r h and total surface area of a cylinder is given by 2 pi r multiplied by r plus h.